Here's a class in the sample project that I called just properties. Probably not the best name for it, but as you can see, it's a pretty contrived example because I want to talk about what automatic properties look like and how you use them. Okay, so I first of all have this property A, and this is a fairly typical pattern, as I've already shown you, of creating properties. I have a getter and a setter method. I'm using a backing field, a private backing field. I return the value and I set the value. So very straightforward. And in this case, whatever this property represents, the code doesn't need to perform any other actions to get or set the value, other than to validate that the value is an integer. That, in essence, is the only checking that's going on here, is type checking. And this is a very common code pattern. It's likely that most of the properties of classes that you create are going to follow this pattern, with a few outliers sprinkled in when you need to perform more complex actions when getting or setting property values. But an automatic property lets you write far simpler code, and here's an example of an automatic property. Again, this is going to implement the exact same pattern as here, but there's really a couple things going on. First of all I need to do is have the public int property. I still need to specify the accessor, public, the data type, the name of the property, but then I include both get and set, which indicates that this is a read-write property. And then the compiler, in essence, expands this at compile time into this, including to create a private backing field for this property B. So the only effective difference between defining the property as an automatic property and, like this, with a backing field, is that because the compiler is generating the backing field, other code within the class or externally does not have access to that compiler-generated backing field. So I won't be able to directly read or write to the backing field for property B. But as a practical matter, all that means is that all of my access to that value need to be through the property name, not directly through the backing field. And that is generally not a problem at all. And in fact, in my own code, even if I define a backing field explicitly, because I have to write some additional code in either the getter or the setter method, I'll do this, I'll define a backing field, but I'll directly access that value through the property name as opposed to directly through the backing field. All right, so that's the only difference between these two things. Otherwise, they're the exact same. And this ends up just being a fancy way of creating two methods in your code. A get method that returns the value. It's going to execute that line of code as a result of including the getter there, and executing that line of code as a result of including the setter. And you can also change the visibility of either the get or the set method. So for example, let's say for property C, I want external code to be able to get the value, but I only want code within the class to be able to set it. So I can change the accessor of the set method to private. And now I can't set this value from external code. Presumably there's some other way to get it. Maybe it's a generated value or something like that, or whatever. But so this is going to change the visibility of the setter method of the property. Okay, and so this is going to be private even though the property itself is public and visible to external data. So you can see where you can start getting really sophisticated with how you define and make accessible the members of your custom class. Okay, so now I want to come over here to a tool that I often use. This is .NET Reflector. It's from Redgate Software. Great company, really wonderful tool. It is a commercial tool. I'm not endorsing it. You could use the tools within Visual Studio. They're not quite as robust. This is a little bit easier to use because I want to show you what happens when the compiler compiles that code. So I've added the assembly for props methods. This is the code that is compiled by that sample application. As you can see, there's the metadata on the assembly, and I can drill down into it and get access to see the code for the different objects. And there's that properties class, and here you can see the fields that are defined. So again, coming back over to the code, B and C don't have explicit backing fields. In fact, if I scroll down here, you can see there's nothing up my sleeves. I didn't define them anywhere else. So I have these automatic properties B and C that I've talked about. All right, so here is the compiler-generated backing field. So you can see the style here is angle bracket B. That's the name of the property, angle bracket. And then it has what amounts to an identifier for this backing field. And as you can see, it also has this attribute of compiler generated, just to indicate that this is something that the compiler generated. Notice that I don't have this same sort of thing for the backing field A because I explicitly included that as _A within my code. If I come back over here, that's that value right there. That's explicitly in the code. That's code that I wrote. All right, so that's included there. So the compiler generated those backing fields for all of the automatic properties that I included within this application. Okay, I can expand methods here, and here you can see the code that is actually generated. A is code that I explicitly defined. You can see that it changes things a little bit in order to make sense for the compilation to IL. But then the automatic properties remain as this, because then it generates the IL code that expands these into code that it can actually execute. All right, so that's just a real quick look at what's going on behind the scenes with automatic properties. Once again, no magic. One other thing I want to point out is that what's a little bit surprising is that this variable name here, this angle bracket B, angle bracket K underscore backing field, is not a valid C# identifier. If you try to name one of your own variables this format, most notably because of the angle brackets in the code there, or in the name there, the compiler would complain. So internally, the compiler is using an invalid identifier format in order to avoid the possibility of any kind of collision with your own identifiers within the class. Now, I could have just called this capital B K underscore backing field, but it's not impossible that you would call something within your own code B K underscore backing field. Highly unlikely, but it's possible. This way, there's no chance of a name collision with your own code. Okay, so that's automatic properties up to and before C# 6.0. So earlier versions implemented automatic properties. They're useful, save a lot of typing over the course of writing an application, but they really weren't fully baked, particularly if you're working with read-only or write-only properties. One of the things that C# 6.0 included was initializers for automatic properties. Before C# 6, there was no way to set an initial value for automatic properties. Now, you could do it in the constructor, you had to write some additional code and so forth, but now, as of C# 6, you can use this syntax right here. So I'm doing the same kind of automatic property. Everything up to there is what you can do have been able to do for several versions of C#. But now you can do this, and this is going to initialize the value of the property F, right there, to 58. So it's really nice to be able to initialize the value of the property right in the declaration. And then the compiler takes care of generating all the code needed to make the property immutable. And the compiler takes care of generating all the code needed to make the property, create the property, and set it to that initial value. All right, and as you can see, it's a very simple, clean syntax, very easy to use. And once again, this is just syntactical sugar. The compiler takes care of generating the code to actually make this happen. And by the way, you're not limited to literal values. You can also execute code, use the value from a method return. So here, a little bit contrived, but you have use for random numbers. So I'm newing up a random number generator, and then setting the initial value of g to a random number that's generated by the next method of the random object. Now, one sort of interesting thing about this is that I had to define this random object with the static keyword. That's because even though the properties class in this sample code is not static itself, notice up here it's not static. Field initialization takes place before the object is properly and completely instantiated. Since the random variable is defined within the same class, it can't require an instance of the class for executing. All right, so that's why it needs to be static, so it's always available. And this is also why the expression that initializes the property can't reference the this object using the this keyword, since this, which represents an instance of the object, doesn't exist yet. So a couple little gotchas in there to be careful of. But generally, if you leave off static here, you'll get a compiler error that indicates what the problem is. And then you can fix that, whatever makes sense. Now there's another aspect of automatic properties that I need to talk about, and those are getter-only or read-only auto properties. In a regular non-auto property, you can leave out either the get or the set method, and that makes the property either write-only or read-only respectively. Read-only properties are useful for property values that shouldn't change or are otherwise outside the control of the class, doing things like reading and returning the value from a hardware sensor. Write-only properties are generally less useful, although they do have some obscure uses. But one of the problems with creating an immutable or read-only property used to be that in order to initialize the property, really the backing field, you'd have to do a few things. You'd first of all have to explicitly define a backing field, which kind of eliminates a lot of the reason for having automatic properties. You also have to initialize the backing field from within the class constructor. You have to include an explicit implementation of the property rather than using an automatic property. And you need to explicitly implement the get method that returns the value of the backing field. And the result of all this is a fair bit of code for what really should be pretty simple. And you have to do this over and over for every read-only property of the class. So the ability to initialize auto properties has a nice side effect. You can now create read-only auto properties. And here's some code that shows how that works. All you need to do is just omit the set accessor and initialize the property with a value. So I just have the getter, so it's read-only, and I have the initializer, and I initialize it here to yet another random number, in this case 1 between 1 and 1,000. The result here is that the compiler declares the backing field with the read-only keyword, although that really matters only when using reflection on the class to peer into its inner workings. The lack of a setter method is what really makes the property read-only. Now, property H is immutable everywhere except in its initializer and in the class constructor. You can still change the value of the property in the class constructor. And you don't even need to initialize a read-only auto property, which might be a bit surprising. Here's an example of that. In this case, you just use the get accessor alone, and the value of the property is forevermore the default value of the data type. And in this case, because property I is an int, it's going to be 0. Okay, now, write-only auto properties are still not allowed. So if I try to do something like this, and I'm not quite sure why that's way over there, let me move that over and do Control S. But if I get rid of that comment, notice that I immediately get a compiler error. And if I hover over it, it says auto-implemented properties must have get accessors. So write-only auto properties are not available. So the idea here is that an auto property doesn't allow you to write any code for the set method that might do something useful with the value. So there really is no apparent usefulness for a write-only auto property. So C# just disallows them. And as I mentioned, you can also initialize auto properties in the class constructor as usual. So I'll comment this back out. And then come up here to, oh, right there. Here are a couple constructors. So notice that I'm using properties H and I. So those are the read-only properties that I created there. But because this is the constructor, I can assign values to those properties. Now when you're initializing them here within the constructor, you have to assign the initial values to the property name and not the backing fields, because I don't have access or direct access to those backing fields at design time. They're created at compile time. And that's what I showed you in .NET Reflector. Okay, and then over here in program.cs, I have some code that exercises that properties class. So I instantiate an instance of the object in P, and I write out the values of A, B, C, F, G, H times F, just to show that I can do calculations with it, and I, and return that value there. Okay. Notice also, have the comment here, that I can't get the value of D. If I come back over here to properties.cs and up to D, the getter is private. So the setter is public, so I can set this, so it's a writable property, but I can't read the value of the property from outside of the class. I can only read it from inside of the class. And so if I remove this comment, see that I get a red squiggly there, and it says the property or indexer properties.d cannot be used in this context because the get accessor is inaccessible. So I get a compiler error. All right, so I'll run the application and select D, and there you can see everything that was going on. Basically all the values, some multiplication, and so forth. Also, I didn't point out that also instantiate a new object there. I pass in some different values using that different constructor for H and I. And so now H is equal to 42 instead of 220. And I is equal to 1957 instead of 0. So again, this is using that constructor where I initialize H and I, which is the only way to initialize them because they're implemented as read-only auto properties.